Hey, welcome back. So before we try to master the art of combining columns from different tables together in our power pivot tables, it's probably worth asking, why does our data need to be broken up into so many different tables to begin with? As you can see here, our example data is split into a number of different files that we'll ultimately be attempting to combine in our power pivot tables. And while this number may seem high, it's actually on the low end when it comes to real-world use cases. So the best way to approach this may be to examine some data that has been combined into a single data set, and then consider why we might benefit from breaking this data up into multiple tables. The example that we'll consider is a number of data points about a few NBA, that is National Basketball Association, players, their positions, the college they attended, their team, their head coach, and so on and so forth. So I've actually got this pulled up in an Excel file, and if you look at this table, you'll see just a record for each of these players. We've got 15 players and a few data points about each of them. And this actually looks pretty convenient. It's kind of a one-stop shop. So why the heck do we need to complicate things by adding new tables when we've got everything we need right here? Well, the problem turns out to be redundancy. So if we sort our little table by team, we see that values in the fields that pertain more to a team than an individual player, like the team name, the head coach, or the team location, keep repeating. And as you might imagine, this redundancy would only grow if we added the full rosters of each of these teams. Right now, we're only pulling in 3 players per team. But if we pulled in the entire roster of, just for example, the Los Angeles Clippers, while you would be getting different information in the first 3 columns about each player, because each player of course has their own name, college, and position, the information about the team name, the location, the head coach, would just keep repeating over and over and over again. So what's the big deal about redundancy? Well, for one thing, by causing the same data to be duplicated over and over again, it wastes space in our data model unnecessarily. And while this may not seem like a big deal now, it can become a real concern as the sheer size and scope of our data grows. But just as importantly, it creates a potential maintenance nightmare by forcing us to update information in multiple places if something changes. So if you follow the NBA like I do, you know that coaches get fired constantly. I believe they call this the coaching carousel. So while Frank Vogel may be coaching the Los Angeles Lakers right now, if they don't win the championship this year, we might find ourselves needing to update that head coach value pretty quickly. The problem is, we have 3 records where he's listed as the head coach. And again, if we had listed the entire Lakers roster, it would be a lot more. So now we need to remember every place that that value needs to be changed when we change it, or else our data will no longer be accurate. Okay, so now we've established the problems redundancy causes us. So how do we eliminate it? Well, that's where breaking data into separate tables comes in. So on our 3rd tab here, you'll see that I gave the players and teams their own respective tables, and gave each record in each of these tables a unique ID in the ID field. So it turns out that there are some very common best practices for data modeling. And while you may or may not be able to design the structure of your own source data, because these are best practices, they're also very common patterns that you'll find in datasets in the wild, especially those sourced from some kind of database. Therefore, it's useful to be able to understand and recognize them. And keep in mind that even if your source data deviates from these best practices, you can always use Power Query to transform raw data to meet your needs before loading it into the data model. So the first best practice is that each table or data set should generally be about one thing. So here we have a table that is about NBA players, and then we also have a table that is about NBA teams. Now going back to our first table, we have these fields, team name, team location, and head coach, which aren't really about the subject of the table as a whole, which appears to be players. If you find that there are fields in your table that don't seem to pertain to the subject of the table, it may be time to think about creating a new table and splitting off those unrelated fields into their own table. Now also, each row or record in a table should represent a unique instance of the thing or entity that table is about. So if this table on our left is about players, then each record should represent a single player. And if the table on our right is about teams, each record should pertain to a single team. Now lastly, each row should have an ID field, like we've added to each table here, which is typically an integer. And that ID should uniquely identify that particular record within the table. This is pretty much the same as the index field that you can add with Power Query. Now this ID field, which again is a very, very common pattern that you'll find in tables and especially data from databases, is commonly known as a primary key. And this process of eliminating redundancy by splitting repeating groups of data off into their own tables is referred to in data speak as normalization. So when we identified these repeating groups of data that appeared to be about something other than the real subject of the table, and then split this information off into its own table, we essentially normalized our data. So now we've solved the redundancy problem. But how will we know how to link the correct team information back to the correct player if and when we want to combine columns from both tables? So we've got this data all neatly split up into two separate tables. But what if, for, just as an example, Jimmy Butler, I would like to pull in his associated team data? How am I going to know, just on what we see here, that Jimmy Butler actually plays on the Miami Heat and that the location of that team is Miami? Well, it turns out that we can do this by establishing a relationship between these two tables. Relationship, as you've probably already figured out, is another word that you're going to hear a lot in regards to data modeling. So establishing relationships can be done via something called a foreign key, and that's illustrated on our fourth tab here. So you can think of a foreign key as kind of a stand-in for all those data points that were being repeated in our combined table example. So if we go back to our combined table where we sorted by team, you see that for our first player here, Patrick Beverley, we have these three data points that really don't pertain specifically to a player, but more to the team that he happens to play for, those being team name, team location, and head coach. So with a foreign key, instead of listing the team, coach, and city for each player in the players table, we simply include the primary key of the associated record from the team table. So for Patrick Beverley, instead of saying that he plays for the Clippers and they're located in Los Angeles and his head coach is Tyronn Lue, we'll simply include the value of the Clippers in the ID field of the teams table. So the ID for the Clippers is 1. So now we just need to put that 1 in the record for Patrick Beverley in the teams table in the team ID column, which is our foreign key. So now anytime we want, we can link this record about Patrick Beverley to the record about the team that he plays for. So now, if poor Frank Vogel gets fired and replaced with Phil Jackson, instead of having to go through all the records pertaining to Los Angeles Lakers players and make that update, we just need to update it in one place. Our team table and the relationship takes care of the rest. So back in our combined table, we would have to update records for Frank Vogel here, here, and here. But using this relational approach, we just have to update the coach's name in one place, and then the relationship will take care of everything else. So here we have Malik Monk, LeBron James, and Anthony Davis, all of whom are associated with the team ID of 3, that being the ID for the Los Angeles Lakers. So as long as these records in the players table all link over to the record in our teams table with that ID of 3, and as long as we change the head coach name in just that one space, we're good to go. The pattern in which the primary key of one table, which is the teams table in our case, can be repeated one or more times in another table as a foreign key, as it is here in our players table, is called a one-to-many relationship, and it is by far the most common type of relationship you'll encounter and the most important one to understand. Now, there are also scenarios where instead of the primary key in this table linking to, say, 3 records in another table, it links to just 1 record in another table. Now, that's called a one-to-one relationship, And it's fairly common as well, although again, much less so than the one-to-many. So hopefully at this point, you kind of get why our example data is broken up into so many different tables, and also how you might identify the relationships between those tables. But when the rubber meets the road, how do we translate our newfound knowledge of table relationships into connecting real data sets in the Excel data model? We'll find that out in the next video. I'll see you then.